Researchers have identified a newly tracked asteroid, labeled 2024 YR4, and while it isn't headed for Earth, its path has drawn attention for a different reason. There is a small but real possibility that it could collide with the Moon. On a cosmic scale, this isn't a catastrophe. On a human scale, it's fascinating, because while asteroids hit the Moon all the time, we almost never know about them in advance, and we almost never get the chance to watch one arrive. 2024 YR4 is roughly the size of a large building. Not a city killer, not a dinosaur-ending monster, but big enough to matter. Big enough to carve a fresh scar into the Moon's surface if it makes contact. Objects of this size are usually discovered late, tracked briefly, and then quietly passed by without much attention. What makes this one different is timing and trajectory. Astronomers spotted it early enough to model its orbit with unusual precision, and the calculations show that the Moon is at least in play. The Moon is already covered in craters, billions of them, layered like geological memories stacked on top of one another. Most were formed early in the solar system's history, when debris was everywhere and collisions were constant. Today, impacts still happen, but they're usually small, pebble-sized meteoroids that leave faint flashes visible only to sensitive instruments. A building-sized asteroid is different. If 2024 YR4 were to hit, it would release energy equivalent to several thousand tons of TNT, creating a crater potentially dozens of meters wide. That's not enough to alter the Moon's orbit or affect Earth, but it's more than enough to be seen. What makes scientists especially interested is that this would be a rare, predictable lunar impact. Most confirmed Moon impacts are discovered after the fact, identified by comparing before and after images of the surface. This time, telescopes on Earth and in space could be watching as it happens. Instruments could capture the flash, the ejecta plume, and the thermal signature of freshly exposed lunar material. For planetary scientists, that's a goldmine. Asteroids like 2024 YR4 are leftovers from the early solar system, fragments that never became planets. They orbit the Sun in slightly unstable paths, occasionally nudged by gravity into the inner solar system. When one passes close to Earth or the Moon, even small gravitational interactions can subtly alter its course. That's why predictions always come with probabilities, not certainties. Right now, the chance of a lunar impact is low, but non-zero. As more observations come in, that probability will either shrink toward zero or tighten around a possible collision window. It's worth emphasizing what this does not mean. This is not a threat to Earth. Even if the asteroid struck the Moon, debris would not rain down on us. The Moon's gravity is too weak to fling material toward Earth in any meaningful way, and Earth's atmosphere would destroy anything small enough to make the journey. The biggest risk here is disappointment. If it misses, we simply lose a rare opportunity to watch cosmic physics play out in real time. Still, the idea of a visible impact on the Moon captures the imagination. The Moon feels permanent, untouched, familiar. We see the same face every night, the same dark Maria and bright highlands. Knowing that it's still being actively reshaped, even slightly, reminds us that nothing in space is truly static. The Moon is not a relic. It's an active participant in a dynamic system. If a collision were to occur, observers on Earth might see a brief flash on the lunar surface, lasting less than a second. It wouldn't be a Hollywood explosion, no fireball hanging in the sky, just a pinpoint of light, followed by nothing. But instruments would see much more. Infrared telescopes could detect heat lingering at the impact site. Orbiters already circling the Moon could later image the new crater, giving scientists a precise before and after comparison rarely available. That comparison matters because it helps refine our understanding of impact physics, how energy transfers through lunar rock, how debris spreads in low gravity, how crater size scales with impact speed and angle. These are not abstract questions. They apply directly to planetary defense research. Understanding impacts on the Moon helps scientists model what would happen if a similar object were on course for Earth, and how effective different deflection strategies might be. There's also a timing element that makes 2024 YR4 especially interesting. Humanity is returning to the Moon. Robotic landers are already there. Crewed missions are planned. Permanent infrastructure is being discussed seriously for the first time since Apollo. A real-time lunar impact would be a reminder that space is not a controlled environment. Even the moon, our nearest neighbor, exists in a shooting gallery of cosmic debris. That doesn't mean lunar bases would be unsafe. The moon's surface area is enormous, and the odds of a random impact hitting a specific structure are vanishingly small. But events like this sharpen awareness. They turn theoretical risks into observable phenomena. They make space feel less abstract and more real. Public interest in asteroids tends to spike when the word impact appears in headlines, even when Earth is not involved. That reaction is understandable. Asteroids sit at the intersection of science and existential fear. They're reminders that Earth exists in a larger system that doesn't care about borders, calendars, or intentions. But they're also reminders of how far our detection capabilities have come. A few decades ago, 2024 YR4 would have passed unnoticed. Today, it's cataloged, tracked, and modeled in detail. That progress matters. Early detection is the foundation of planetary defense. You can't respond to what you can't see. Even when an object poses no danger, tracking it builds experience, improves algorithms, and tests coordination between observatories worldwide. Every asteroid tracked is a rehearsal for the one that might actually matter. There's also something quietly poetic about the moon possibly taking the hit instead of Earth. For billions of years, the moon has acted as a partial shield, absorbing impacts that might otherwise have reached us. Many scientists believe the moon's presence has played a role in stabilizing Earth's environment, contributing indirectly to the conditions that allowed life to evolve. A small asteroid striking the moon today would be just another chapter in that long, protective relationship. Whether 2024 YR4 hits the moon or not, the story doesn't end in disappointment. A near miss is still valuable. It still provides data. It still refines orbital models. It still improves our ability to predict future encounters. In astronomy, nothing happened is often just as informative as something happened, especially when predictions were involved. For skywatchers, there's a subtle shift in perspective that comes with stories like this. The moon stops being just a familiar object in the sky and becomes a place where events happen, where impacts occur, where change is ongoing. The night sky feels less like a backdrop and more like a stage. If an impact does occur and is observed, it will likely be remembered not as a disaster, but as a scientific milestone. A rare chance to watch the solar system operate in real time. A reminder that space is active, evolving, and occasionally dramatic in ways that don't threaten us, but still demand attention. And if it doesn't happen, if 2024 YR4 slips past the moon and disappears back into the dark, that's fine too. Because the real headline isn't the collision. It's the fact that we knew it might happen at all.
Thanks for watching. If you enjoyed this journey through the cosmos, hit like, subscribe, and tap the bell. And when you're ready for your next space mystery, click the video right here.